In the lecture, we will learn how to define seismic load in ETABS and how to actually apply it on the structure. Seismic load is also called earthquake load, and we will be using ASCE 7-10 for applying it to our structure. The seismic load is a function of the code, whatever code you are using. So seismic load will be applied using that code. The structure which we will be applying to seismic load is situated in South Carolina, United States of America. That's why we'll use the American code. The site class given is site class B. It is obtained from the soil report. The importance factor for this structure is 1 from ASCE 7-10 code. The structure is dual system, shear wall and special moment resisting frames. And the risk category for the structure as per ASCE 7-10 is 2. It can be obtained from ASCE 7-10 chapter number 1. The seismic load for our structure needs certain parameters to be defined. Let's proceed with ETABS. For defining seismic load, we need to go to define load patterns. We have to apply seismic load in X direction using ASCE 7-10 code and click on add new load. Similarly, seismic load in Y direction. For earthquake in X direction, click on modify load. You need to uncheck the Y directional loads. Eccentricity ratio for the diaphragm using code minimum of 5%. That means when the earthquake load will be applied to the structure, it will also be applied at a 5% eccentricity, causing a twisting moment. The calculation of time period by approximate method and program calculated method. We need the function of CT and X. The seismic load is applied to the superstructure, so the base of the structure should always be at natural ground level. No underground structure should be included in, and the top story shall be included for the roof. Response modification factor, overstrength and deflection amplification can be obtained from the code. SS and S1 values can be obtained from the maps. I am using ASCE 7-10 maps. SS is the short period spectral acceleration. For North Carolina, we have 1.5 times of gravitational acceleration, that is 150% of g. The value of SS for North Carolina is 1.5 as obtained from the map. Similarly for S1, the value is 0.6. As the map is given in percentage, so we need to input it in fraction. The map is for 5% critical damping and site class B, consisting of maximum credible earthquake ground motion data. You can obtain these maps from the code you are using or USGS website. Long-term transition period is also given in maps. I'm using ASCE 7-10 code for United States. So our location is somewhere here. So the long-term transition period is 8 seconds. The design spectral acceleration is calculated automatically by ETABS. For response modification factor, we need to go to ASCE chapter 12, table 12.2-1. The value of R is 7, the value of overstrength factor is 2.5, the value of deflection amplification is 5.5. The importance factor, as already told, is 1 for the structure. The value of CT, again referring to ASCE 7-10 code, 0.02, and X value is 0.75. From this, we need to get the seismic design category. Seismic design category for our structure is seismic design category D, which we have to define in ETABS. Similarly, we have to add all these things in Y direction as well. Still, the earthquake load is not applied to the structure. We need to go to 3D view and only select the shell elements, including floors. Select the floors, all of them, and go to define diaphragms. Diaphragm distribute the lateral load to the lateral force resisting elements, which in our structure is the shear wall and the columns, as we are dealing with a dual frame system. The diaphragm is to be selected for rigid. If we have reinforced concrete structure, semi-rigid will increase the degree of freedoms for the model. It will include in-plane bending and increase the analysis time, but rigid sometimes is considered as conservative. So we'll assign a rigid diaphragm to the shell elements for distributing the lateral forces to the vertical elements, that is columns and shear walls. That is the center of rigidity. Now you can reset the visibility. If you need to see the rigid diaphragm visibility again, you can click on diaphragm extend. Now one more step for defining and applying the earthquake to the structure. We need to go to mass source. Mass source is the parameter which will take the weight of the structure to account for earthquake base shear. The best way is to include specified load patterns. As I am using ASCE 7-10, it specifies us to take the dead load as 100% and live load as 25% or sometimes 0.2%, 0.2 times. Now our earthquake load is applied to the structure. For design of concrete frame, we need to select the seismic design category as D, which has already been selected. Similarly for shear walls, and for slabs. That is how we assign earthquake